diesel-electric heavy-haul freight locomotive works. Diesel-electric locomotives have remained popular for over 60 years. As a measurement of capacity, they can take a 2,000-pound chunk of freight nearly 500 miles on 1 gallon of fuel, which is 3 to 4 times more efficient than a semi-trailer truck. Let's start with the body and frame. Most modern freight locomotives are hood units with a slim middle section and walkways on the outside of the body, allowing visibility in both directions. The nose portion is full width or wide cab. Locomotives mostly run short hood first, as designated by the decal letter F for front. Metal body panels can be opened or removed for maintenance or emergency access. Main sections are the nose and operator's cab, auxiliary or aux cab, which is packed with electronic components, the engine, and radiator cab at the rear with various cooling components and the onboard air compressor. The body and critical components are supported by a thick steel or steel alloy platform called the underframe. A pilot or cowcatcher sits at the front to deflect obstacles that could derail or damage the locomotive. There's an overhang called the anti-climber that prevents deflected objects from flying into the cabin. Concealed collision posts on each side further protect the cab in the event of an accident. There's a unique ID number displayed on the front and sides. A set of air horns sits on top of the body, and there's an electronic speaker attached to the underframe to emit a bell sound. A large manual handbrake wheel is visible near the rear. Coupling. Locomotives can couple with other locomotives or train cars. There are various coupler types. Our locomotive has a more complex Type F coupler versus the simpler Type E style on a train car. Type F, for example, has robust side features to prevent vertical movement in accident conditions, where Type E requires no such protections. Couplers are designed to work by bumping into one another. They'll couple in various arrangements, for example, with both couplers open, or one closed and one open. As knuckles make contact, their rounded shape causes rotation that presses against the knuckle thrower. Which in turn moves the lock. The lock rides along an internal channel and also rests on a sloped feature at the back of the knuckle so that it naturally slides into locking position as all parts reach the end of their travel. For uncoupling, there's a manually operated bar called the pin lifter or cut lever. When rotated, parts operate in a reverse sequence to coupling. The lock rides upwards, pressing the knuckle thrower, which rotates the knuckle into open position. The coupler is attached to the draft gear assembly, which provides a kind of suspension between train cars. During impact coupling, also known as a buff event, the coupler is forced backwards against the draft gear, which compresses an internal stack of rubbery discs. The draft gear's rearward travel is stopped by thick metal tabs at the back. When train cars pull away from each other, also called a draft event, the surrounding yoke pulls the draft gear against a block at the front, causing the internal discs to again compress and absorb potentially harmful forces. When cars are coupled together, A hose is also connected to supply air for individual car brakes, and a cable for cars equipped with electronic brake support devices. More about these systems later. When multiple locomotives are coupled, the MU, or multiple unit connector, brings mechanical, engine, and electrical systems under control of the lead locomotive. The connector sits in a dummy receptacle when not in use. 3 additional hoses synchronize braking operations between locomotives. There's the main reservoir hose, the actuating hose, and the brake cylinder hose. Engine. A 12-cylinder, twin-turbo, 4-stroke diesel engine, called the prime mover, is the power source for this locomotive. Fuel is supplied from reinforced walled tanks mounted beneath the underframe. These tanks can carry 5,300 gallons of fuel. The fuel injection system has a pump for each cylinder bank, with multi-walled tubing between cylinders designed to handle high pressure. To decrease noise levels and increase efficiency, as many as 8 different injections of fuel are made during a single combustion cycle, as determined by sensors in the fuel system. Engine support components are mounted nearby, including a lube oil tank and oil filters, fuel filters, and more. Turbocharging. This engine has 2 turbochargers to efficiently supply the engine with more air for combustion. There's a charge air cooler nearby to cool turbo air before it reaches the engine, since cold air is more dense and better suited to the goal of pumping more air into the engine. The charge air cooler has 2 sides, one for each turbo. These turbos are arranged in what's called a compound sequential configuration, which functions as follows. At lower RPMs, exhaust gases can more easily spin up the smaller turbo, whose compressor wheel begins to take in air. Air enters through a side port and flows through the large turbo before entering the small turbo. It's then cooled on its way to the engine intake. The large turbo is not yet fully powered. As RPMs and resulting available exhaust energy increase, a valve opens, spinning up the large turbo. While the small turbo is easier to rotate at lower RPMs, it's also designed to handle higher overall pressures. As such, the large, low-pressure turbo now directly feeds all of its air to the smaller, high-pressure turbo, and the whole system delivers maximum airflow to the engine for peak performance. To dramatically reduce certain pollutants and exhaust gases, these diesel engines are equipped with an EGR, or exhaust gas recirculation system. A valve allows exhaust from the left cylinder bank to enter the EGR system, where it passes through a water cooling unit before being mixed with fresh incoming air. Sending some exhaust gas back through the combustion process lowers combustion efficiency in favor of greatly reducing exhaust pollutants overall. 1. To save costs and avoid potentially hazardous antifreeze leaks, water is used for various cooling duties. A large tank holds nearly 400 gallons of water. An engine-driven water pump supplies pressure to the system. There are large banks of radiators with external shutters to help manage airflow. An oversized fan pulls outside air past these radiators as water courses through internal tubes. This cooling water flows to the engine, EGR cooler, turbochargers, air compressor, and more. During cold weather, it also runs through the fuel system preheater to warm the fuel before combustion. If the locomotive is not running and temperatures drop below 40 degrees Fahrenheit, automatic water dump valves open, draining the system to prevent freezing. Electrical. The diesel engine